Okay, welcome back to Mr. Hassan's Maths channel. I'm going to answer question number 6 now from the October 2022 Pure Mathematics P4 exam. This question is about this parametric equations and this curve. So it says figure 3 shows a sketch of the curve C with parametric equations x equals 1 plus 3 tan t and y equals 2 cosine 2t of t values between minus pi over 6 and pi over 3 both included. The curve crosses the x-axis at the point P as shown in figure 3. Find the equation of the tangent to C at P, writing your answer in the form y equals mx plus c, where m and c are constants to be found. So the tangent to a curve is a straight line which brushes the curve at that point, which is the tangent, and it has the same gradient as the curve at that point. So the tangent to the curve at the point P would be something that looks somewhat like this. It's going to have the same gradient at the point P, and it's going to just touch it at point P. So the tangent is basically a straight line. And to find the equation of a straight line, we need two bits of information. We need to know the coordinates of the point that it passes through. And we want it in the form y equals mx plus c, right? So we want to know the coordinates of the point that it passes through, which is P, which is basically x, P, and 0. We know the y coordinate of P is 0. And we need to know the gradient of the tangent. Okay, these two things are what we need to know. So we need to find the y coordinate of P and the gradient of the tangent, and that will help us to find the equation of the curve, of the straight line, sorry, which is the tangent. Okay, so this is the line which is the tangent to the curve. So how do we go about finding these things? So I need to find the y coordinate at this point P. I don't have what the value of t is at the point P. They didn't tell us, all right? They didn't say at P, t is equal to such and such. However, we know that P is the place. So we need the x coordinate of the point P, sorry. Okay, we already have this. What I'm talking about. Excuse me there. We want the x coordinate of the point P. We have the y coordinate 0, as I wrote down. Okay, so we already have, as I said, the y coordinate. We need the x coordinate. We don't know the value of t at P. However, we know at P, y equals 0, as we just mentioned. So I know that at P, y equals 0. So 2 cosine of 2t is equal to 0. So I have to solve this equation, but my limits are between minus pi over 6 and pi over 3 for t. Now, because it says 2t, all right, I have to change these limits, multiply this by 2. That's going to be minus pi over 3. Less than equal to 2t less than 2 pi over 3. So I can go up to 2 pi over 3, which is like more than pi over 2. So this is going to be 120. So this is like in degrees 120, and this is in degrees minus 60. So we can go more than 90 degrees. This is where it's going to go to. So we know that the cosine of 2t equals 0 from this, divided by 2. So 2t is equal to the inverse cosine of 0. Now, where does the cosine curve hit 0? The cosine curve hits 0 at pi over 2. Right? The cosine curve hits 0 at pi over 2. And if we're not sure of that, we make sure our degrees calculated in radian mode. Shift cosine of 0, and it's going to give us, pi over 2. Okay? So that's the answer in our range. There's no answer in our range because the other place will be further than this, and it's going to be less than this. It's going to be minus pi over 2, the other place where it's going to be positive. So yeah, so we're going to have that. Therefore, 2t is equal to pi over 2. Okay, therefore t is equal to pi over 4. So we know at P, t is equal to pi over 4. So therefore, we can say x is equal to 1 plus 3 times tan of pi over 4. So x is equal to, so we know that tan of pi over 4 is 1. So you have 1 plus 3 times 1, just to confirm and make sure, and just for to make your minds at rest. That's going to give us 1 plus 3, which is 4. So x equals 4. So I know the coordinates of P are 4 and 0. Those are the coordinates of the point P. Now we need to find the gradient at P. Okay, the gradient of the curve at P. So what we have to find we need to find the gradient of the curve at P. So we need an expression for dy dx. And we know dy dx is equal to, if we got this in this form, it's dy dt times dt dx. And we know that y is equal to 2 cosine of 2t. So dy dt is going to be, if you differentiate this, you're going to have cosine becoming minus sine. So you're going to have 2 times minus sine of 2t, then multiplied by 2 because of the chain rule. You differentiate this as normal, and then you multiply by the differential what's inside the function. So that gives us negative 4 sine of 2t. That's dy dt. Okay, so this is negative 4 sine of 2t times dt dx. So we got x is equal to 1 plus 3 tan of x. Okay, t, not x, t. Right? And we got to find dx dt. So dx dt, well, the 1 becomes 0. And tan t, when you differentiate, becomes secant squared t. So that's 3 times secant squared t. Okay, which is the same as saying 3 over cosine squared t. Okay, so this is times, now dt dx is the reciprocal of dx dt. So it's going to be times cosine squared t over 3. All right, so you end up with minus 4 over 3 times sine of 2t times cosine squared t. That is dy dx. Okay, so we want to find the gradient. Okay, the gradient at t is, we know that at that point t equals pi over 4. At p, t equals pi over 4. So what I want to find, the gradient of the tangent is going to be when I replace the t here with pi over 4. So I have minus 4 over 3 times the sine of, and instead of t I put pi over 4, that's the sine of pi over 2 times the cosine of pi over 4 squared. Okay, remember this is the same as cosine t all squared. So that will give me the gradient of the tangent. So the gradient of the tangent is minus 4 over 3. The sine of pi over 2 is 1. And the cosine of pi over 4 is root 2 over 2. Okay, so you got cosine of pi over 4. Okay, I know that's 1 over root 2 or root 2 over 2. Okay, so that's times root 2 over 2, but that's squared, right? So you have minus 4 over 3 times 2 over 4. That cancels that. You're left with minus 2 over 3. So the gradient of the tangent is minus 2/3, and the coordinates of P are 4 and 0. So I'm going to go to the next page, and I'm going to write down the equation. I'm going to work out the equation. So we know that it goes through. We know the gradient is minus, I forgot already, minus, what was it, 2 over 3? Yeah, minus 2/3 and 4, 0. So minus 2/3, and we know the point P is going to be 4 and 0. Okay, so we want to find the equation of the tangent. We have y minus y1 equals m times x minus x1. So you have y minus 0 equals m, which is minus 2/3 times x minus 4. Now they want us to give the answer in what form? In the form y equals mx plus c. All right. So what I'm going to do is I'm just going to write this as y equals minus 2/3 x plus 8 over 3. And there's the equation of the tangent to the curve at the point P. Okay, at the point P. And there's the answer to part A. Okay, pretty simple. Now for part B. It says the curve has equation y equals f of x, where f is a function with domain k and 1 plus 3 root 3. Find the exact value of the constant k. So this curve that we've been dealing with, this is its domain. Okay, now the domain is determined in a parametric equation by the x part of the equation. That determines the domain of the curve, and this part determines the range of the curve. So here we're asked to find the domain of this curve. Okay, we're asked to find one of the limits of the domain of this curve. So whenever you want to find the range and domain of something, the best thing to do is to make a sketch. So what I'm going to do here is I'm going to sketch x against t. So our x-axis will actually be vertical here, right? It's like the output of this, The output of this will be our domain of this of our main function. The output of the x part is the domain of this function. The output of the range of the y part is the range of this function. So I'm going to make a little sketch of this function. Okay, it's between minus pi over 6 and pi over 3. Okay, between minus pi over 6 and pi over 3. All right, so this is the tan curve. We know the tan curve has asymptotes at pi over 2 and minus pi over 2, which will be way away from where we are, actually. It won't be close to where, it'll be further along and further behind where we are. Just make sure this is straight. Okay, so you'll have an asymptote and another asymptote. All right, over here somewhere, which won't affect us because we're not in that range. So minus pi over 2 and pi over 2 are the asymptotes for the tan curve. All right, and this is 1 plus 3 tan t. So basically, where will this hit the x-axis? The tan curve normally goes through this point. Okay, there's no horizontal transformation, just vertical. It's going to be raised by 1, so it's going to cross at 1 here, and it's going to look something like this. It's going to look something, if I drew the whole thing, it would up to minus pi over 2, it would look something like this, and it'd go up, and it would go up to there. All right. However, we have our limits for this between minus pi over 6 and pi over 3. Now, pi over 3 is like around 60 degrees, so it's less than this. Pi over 3 is over here. And minus pi over 6 is like 30 degrees. So it's going to be, even, it's going to be less than this. It's going to be somewhere over here. The exact point we have to, in terms of where it crosses, we can kind of figure that out. But let me just work out what it's going to be. Minus pi over 6. Let's see what minus pi over 6 gives us when we put it into here, and then we can figure out where to place it. So you have 1 plus 3 times tan of negative pi over 6. Whoops. Negative pi over 6. Shift. Okay. And that will give us, it gets to 1 minus root 3, which is, okay, so it's going to be negative. So it's going to be down here. Negative pi over 6 is going to be over here somewhere. So I should have drawn this a bit. Let me just draw this part again. You don't have to actually draw it, to be honest, but it's always good to have an idea of what it looks like. It's going to go something like this. All right. And it's going to be, say this is minus pi over 6. That's where we're stopping. We're stopping here. Okay, at minus pi over 6. So I don't have this section of it here. This section doesn't exist. And this is going to be the other place where it stops. And we don't have any section on this. This is how the curve looks. So its domain because we are sketching the x part. With the output of this is the domain of our function. All right. So the output of this is the value between here and there. Okay. So this between here and here will give us the output of this function. Okay. The output of this function, which will be the domain of this function. Right. So this represents the domain of that function because that's the input of that function. You could say that's the x part. So what is the lowest part and what's the highest part? Well, they said the highest part is 1 plus 3 root 3. Okay, that's 1 plus, up here, 1 plus 3 root 3. Okay, and we can confirm that by putting pi over 3 into here. And if we do that, if we put pi over 3 into here, we should get that just to confirm. Just get rid of the minus sign. Okay, that gives us 1 plus 3 root 3, which is exactly what we got there. So that confirms that that's the highest. And the lowest is going to be, as we just saw, when we put minus pi over 6 in here. Okay, because that's the limit that we have there. When we put minus pi over 6 in here, it will give us this value here, which is the lowest it reaches. Okay, so you press equals, it gives you 1 minus root 3. So this is 1 minus root 3. So therefore, we can say that k is equal to 1 minus root 3. Okay, so when you put x equals 1 plus 3 tan t, when we put t equals negative pi over 6, we end up with this. Okay, so that is a lower limit. So there's the answer to part B. Okay, that's the value for the k there. Now, for the domain, for the range of the function, what is it that affects the range of the function? Well, it's the y part of the parametric equation. Okay, so it's going to be this part here which affects the range. Okay, so we've got to think about this curve. All right, so this has got 2 cosine 2t. So we know that if we draw this curve, okay, if we draw this curve, I'm going to just make a little sketch of it. All right, we've got this is going to be our t-axis. Oops. This is our t-axis, and then we also have our x-axis, or our y-axis. Sorry, this is y this time. This is y against t. One second, let me just get rid of this. This is y against t. Okay, so we have y against t to find the range. Okay, now between minus pi over 6 and pi over 3. So I'll put minus pi over 6 and up to pi over 3. Let's say we have to go up to pi over 3. Now the cosine curve will normally look like this. All right, it will normally look like this between 0 and 360 degrees. And it just continues on like that on the other side. It's kind of symmetrical. And this is pi over 2. All right, now this is going to be slightly different because 1 is going to go as high as 2. That's the highest it's going to reach, not 1, because it's 2 times. So it's going to have a vertical stretch of 2. And 2, what's going to happen is it's going to be horizontally transformed as well. So instead of going through pi over 2, it's going to, instead of crossing in this case, the t-axis at pi over 2, it's going to cross at pi over 4. Now, pi over 4 is less than pi over 3, right? And instead of hitting minus 1 at pi over 2, it's going to hit minus 1 at pi over, minus 1 at pi, it's going to hit minus 1 at pi over 2. Instead of hitting minus 1 at pi, it's going to hit minus 1 at pi over 2. It's horizontally stretched. Right now, pi over 2 is more than pi over 3, so it's not going to quite reach its bottom limit of, in this case, minus 2 because of this. It's going to go something like this. So it's going to go like this, and then it's going to start heading back towards a minimum, but it's going to stop here, and this is going to be at pi over 3. And minus pi over 6 is going to, it's going to stop at minus pi over 6 over here somewhere. Just move this along here. Right, it's going to have this kind of look to it. That's going to be minus pi over 6 on this side. Okay. And it's going to be pi over 3 on this side. It hasn't quite reached its minimum. Minimum is going to be at minus 2 and pi over 2. That's where it's going to reach its minimum, but it doesn't go that far. Okay. And it stops here. It doesn't get to 0 here. So we can see that the range of this function here, okay, we can see that the output of this y, of these y values, is between that point and this point. All right. So between those values there, we're going to get our range. Okay. That will be the output of this y values, therefore the range of our function. Okay. So we got to think about, we can see the highest value is definitely 2. Okay. That's the height it reaches is 2. What's the lowest it reaches? Well, it's when you put, we're not going to put minus pi over 6 to find the lowest value. Why? Because it goes above that and then comes down again. Right? It goes above that and comes down again. So we're not going to use this as our highest value. That's our highest value. Okay? Because when t equals 0, it's within our range, and that gives a higher value when t equals minus pi over 6. So it doesn't mean we put this value in to find the lowest one and this one to find the highest one. We see what happens in between that range. Where does it reach its highest possible value in that range that we have? Well, it's when it's at 2, when t equals 0. And the lowest value you can reach is when t is pi over 3. Okay, so when t equals pi over 3, we have y equals 2 times cosine of 2 pi over 3. So we can put that in a calculator. We have 2 times the cosine of 2, let's see, 2 pi over 3. And that gives us our lowest value, which is minus 1. Okay, so this is a minus 1. It doesn't go down as far as minus 2, right? So we can see that the range is going to therefore be given by y values between minus 1, including minus 1, and 2, including 2. So that's the range of this function. So the y part gives us the range, the x part gives us the domain. Okay, so that's how we deal with such functions here. All right, so it's something that we should understand how to deal with. All right, don't think that it's, I mean, a lot of people would just put minus pi over 6 inside this, okay, and say that's going to give us the range. All right, that's going to give us one limit of the range, and putting pi over 3 will give us the other limit of the range. Okay, it doesn't work like that. You think within these values of t, okay, what's the highest that this curve will reach, and what's the lowest that it will reach in these values, within these values. And the highest is the higher limit of the range, and the lowest is the lower limit of the range. Okay, and it's the y part of the parametric curve that tells us about the range of the function, and it's the x part of the parametric equation which tells us the domain. Okay, so that's how we have to understand. In this particular case, the lower limit did give us the lower part, and the higher limit did give us the highest part because of the shape of this curve. But this is different. It goes up and comes down again. So it has a maximum point which comes in that range. Okay, within those values of t, there's a higher value than what you get when you put this in there. Okay, so it's very important for you to understand how to deal with that. Okay, so that concludes this question number 6 from October 2022. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of parametric equations can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can click on the link here. It will take you to a video which shows you how to use my channel effectively. Thank you for watching, and see you soon.